spherical refracting surfaces. Basic assumption. Basic assumption in dealing with spherical refracting surfaces. Number 1, object taken, point object, aperture small, to minimize a defect. Spherical aberration, sharp इमेज नहीं बनती, लार्ज अपर्चर है. Aperture small to minimize a defect called spherical aberration. What is defect? Spherical aberration, no sharp image. Angle of incidence be small. Sign conventions. What is spherical refracting surface? A sphere of glass. This is spherical refracting surface. It is total glass. Sign convention. Object always on left hand side. Of pole. Distance distances be measured from pole of spherical surface. Third, distance along incident ray. Distances along incident ray are taken as positive, otherwise negative. In dealing with the spherical surfaces, we will assume these three things: basic assumptions, object, point object, aperture small to minimize defect of spherical aberration, angle of incidence small. Sign conventions, object always left hand side, distance we have done this up to metric. Object always left hand side, distance be measured from pole, distancing along incident ray are taken as positive, otherwise negative. This means this third, left में जितने distances होंगे negative, right में positive. किसके? इसके spherical surface के. derive convex spherical surface formula when ray of light goes from rarer to denser medium and image is real. This is a question. This is glass and one surface of this glass is convex. This is convex spherical surface. This is principal axis pole. This is center of curvature. This is point object. Point object, left hand side. This is incident ray. This will be normal. Any line joining C will be normal to curved surface. This is I. This should be small. Bend towards normal. This is image. Because second ray pole directly they meet at I, image. This is R. So first is draw rays through convex spherical surface for formation of real image. Goes from rare to denser medium. N2 absolute refractive index, N1 absolute refractive index. Let I is point image of object O in convex spherical surface of small aperture. As aperture is small, PM nearly a straight line and perpendicular to principal axis. This is aperture small and point is nearly here. Here it is nearly perpendicular and a straight line. And one absolute refractive index of air, rarer medium, and two absolute refractive index of glass, denser medium. We know this thing, N2 by N1 Sin I by sin R. Sin I, sin R. We know this thing. Rare to denser. Sin I by sin R. We have to apply this. So, N1 and 2 shown. I, R. To find I and R, take base angles. Theta, alpha, phi. We will apply this, but this is the solution. To find I and R, we take these base angles. This is the right angle triangle. Yeah, this is perpendicular, nearly perpendicular, straight line. Tan theta. PM by PO. Tan alpha. This is alpha. PM by PC. Tan phi. PM. Phi is this. This is that right angle. PI. Aperture small. So M point is here. Here. So these angles will be small. If these are small angles, then theta. PM by PO. Alpha. PM by PC. Phi. PM by PI. As theta, alpha, phi are small angles. Why these are small angles? Because of aperture. What I want to find? I and R. I in triangle. This is I. Look, MOC. I is external angle of triangle. MOC. I is theta plus alpha. MOC. Theta plus alpha. Theta. Theta is PM common 1 by PO. Alpha. PM common 1 by PC. We have found I. Sin R. Sin R is in triangle. MCI. Okay. MCI. In this triangle, external angle is alpha. Alpha is external angle. It is R plus phi. We require R. R is alpha minus phi. Or R is alpha. PM common 1 by PC minus phi. PM by PI. We know. N2 by N1 sin I sin r n2 by n1 I by r. I basic assumption small, r again small, it is less than I. ये लेके चले थे हम स्मॉल एंगल्स I as I and R are small angles. N2 into R, N1 into I, N2 R. This is R. PM 1 by PC minus PM was common, one by PI and 1 I. This is I. PM 1 by PO plus 1 by PC. PM goes with PM, N2 by PC, N2 by PI, N1 by PO, N1 by PC. करो इकट्ठा इसको PC को, N2 minus N1 by PC, N1 by PO plus N2 by PI. So this is number 1. PO, object from pole, it is U. PI, image from pole, it is V. PC, center of curvature from pole, it is R. Now this is on left, minus, right. Third sign convention, distance along incident ray are taken as positive. This is direction of incident ray. So these distances will be positive and this distance will be negative, or left, negative, right, positive. Putting in first N2 minus N1 by R, N1 by minus U, N2 by V, or it is N2 minus N1 by R, N2 by V minus N1 by U. This is spherical surface formula for convex. Spherical surface for real image when rays goes from rare to denser medium. Again, convex spherical surface. This is principal axis pole. This is C. Take object very near This is incident ray. This is normal. Instead of towards, bend away from normal. This is I. This is R. Appear to meet. This is image. Same. This is N2. This is N1. This point is capital N. Let I is virtual point image of point object O in convex spherical surface of small aperture. As aperture small, PM is nearly straight line and perpendicular to principal axis. Let N1 absolute refractive index of air or rarer medium, N2 absolute refractive index of glass or denser medium. Same things, same. क्या लगाना है भाई? N2 by N1 is sin I by R. Why? Rays goes from rarer to denser medium. So take angles. This is say theta, this say alpha, this phi. Why? We want to find I and R in terms of these angles so that we can get a solution. I is external angle of this triangle, in triangle MOC. I tan theta. Tan theta is PM by PO. PM by PO. Tan alpha, it is PM by PC. This is alpha. Tan phi, it is PM by PI. Or theta, PM by PO, or alpha, PM by PC, or phi, PM by PI. As these are small angles. Why these are small angles because aperture is small, so M point is here, here. Now, find I. I is in triangle MOC. In triangle MOC. I is external angle. I is theta plus alpha. Theta. I is theta. Theta is this. PM common 1 by PO. Alpha. PM was common 1 by PC. And R. R is in this triangle. Look, this is R. Is external angle of this triangle. In triangle MIC. R is external angle. It is phi plus alpha. Phi PM common 1 by pi plus alpha. Alpha 1 by PC. We know n2 by n1 sin I by sin R, or n2 by n1 I by R, as I and R are small angles. n2 into R, n1 into I, n2 into R. R is this, PM. R is this, PM. This one, 1 by PI, 1 by PC, n1 into I. This is I, PM. 1 by PO plus 1 by PC. PM with PM, N2 PI, N2 PC, N1 PO, N1 PC, or N2 minus N1 by PC. Take this side. Take this side, minus N2 Pi plus N1 PO number first. Now, PO, object pole से, it is UPI, image pole, it is V, PC, it is R. Only PC is positive, right side, both are negative. Putting these values in first, N2 minus N1 by R, minus V, minus, so N2 by V, N1 by U, plus this is minus U. So So the spherical surface formula is same whether image is real or virtual in convex spherical surface. Now again, concave spherical surface formula when ray goes from rarer to denser medium. Only one image is formed, that is virtual image. Convex, both images were there. Real, virtual. Here only virtual. Ray goes from rarer to denser. Say this is object. This side there will be C. This is incident ray. This will be normal. This is I. It will bend towards normal. This is R. So this will be image. Let I is image, point object O, in concave spherical surface, small aperture small. This is nearly straight line and perpendicular. N1, N2, absolute refractive index as already discussed. Same thing, N is N2 by N1, sin I by sin R. Y rays goes from rarer to denser. To find I and R, theta, alpha, right base angles. Tan theta. Tan theta is PM by PO. Tan alpha, PM by PI. Tan phi, PM by PC. Theta, PM by PO. Alpha, PM by PI. Phi, PM by PC as angles small. Now I in triangle, I angle is MCO. In MCO, phi is external angle. Phi, it is theta plus I. Therefore, I, phi minus theta, phi, this is phi, PM common, 1 by PC, theta, 1 by PO. So I we have find out R. This is normal. This is back. So this angle will be R. This is R. This will be R. This angle. So in triangle MCI, if this is R, this will be R. This one. In MCI, phi again R plus alpha or R, phi minus alpha, phi Pm 1 by Pc minus alpha 1 by Pi. We know n2 by n1 sin I by sin R, or n2 by n1 I by R, or n2 into R n1 into I. Why I and R are small angles? n2 R was this. Pm 1 by Pc Pi. N1 I is this. Pm 1 by Pc Po. Pm with Pm, N2 by Pc, N2 by Pi, N1 by Pc, N1 by Po, or N2 minus N1 by Pc. Take Pc this side, N2 by Pi. N1 by PO. This is number first, but PO object pole U, PI image pole V, PC center of curvature pole R. All 3 are to this side, so negative. Putting them in first, n2 minus n1 by minus R, n2 by minus V, n1 minus U, minus common from here, cancel with this minus, or it is n2 minus n1 by R, n2 by V, n1 by U. So formula is same whether surface is convex, concave, and ray goes from rare to denser medium.